Hello friends, I am Neeraj Shukla, the owner, founder and CEO of Skolenberg International Private Limited. Pleasantly welcome you to this course that is Basics of Marine HVAC System Design. I am so super excited and I was waiting for this particular day to happen because there's so much to tell, so much to learn about this particular topic. As you are already aware that HVAC is a huge ocean in by itself. It has a residential sector, commercial sector, industrial sector. So each sector has its own peculiarity, each sector has its own application. Then you have a courtroom sector, then you have even this healthcare sector, then you have your clean room sector. So it's a huge ocean altogether. In every aspect of our life, the HVAC is required. And nowadays, it is a trend and it's mandatory, you can say. If you go to Gulf, definitely any building cannot be HVAC because HVAC is a basic necessity for the life there to survive, to have a better productivity. So over the period of time, people have understood the importance of HVAC. But, here's a big but. Okay, big but is that a big clause, a big stopover is that when it comes to marine HVAC, listen to me carefully. When it comes to marine HVAC, in marine HVAC you have ships, you have oil and gas platforms, you have onshore sector, offshore sector, hydrocarbon, refineries, upstream, downstream, whatever you call it. In marine HVAC, there is very limited knowledge available in the public domain. Very limited knowledge. You just go to Google, YouTube. Very limited knowledge and basic knowledge you will get on the marine HVAC system. And you know the secret. Marine HVAC, in fact, is the highest paid profession for an HVAC engineer. Yes, people get in marine HVAC, the people get up to 10 to 15,000 US dollar per month. That much package they can easily get in Gulf. Easily they can get it in Gulf. If they focus and make their fundamentals right and they learn proper things, they learn from proper people, so the proper sources, proper material, proper institute, then they can do it easily. Entry to this field is not as difficult as it seems if you focus it and do the things correctly as I am telling you. Me being the mentor who has worked in this industry for more than 20 years, who else can tell you the secrets of this? Whatever I know, I just want to give it to you guys so you can progress in your life. So just focus what I'm saying and do what I say, and this is what the course I want to begin with. So to start the course, you need to understand the basics of this particular sector. What are the basics? What does it mean? Because when I say certain terminologies, you must understand what it means. So this is what this entire module which I've designed or which I'm giving this presentation all about. It's all about you guys to know that when I say certain terms, say bulkhead or deckhead, what does it mean? So once I say, you can easily correlate. So listen to me very carefully, module by module, topic by topic, slide by slide. Then only we can move on to the next session. Okay. So this is altogether different experience for you guys. So just focus it carefully because whatever I'm going to tell you, nowhere you will get, that's my assurance and guarantee. Nowhere you will get. Nobody is there to tell you what it is. But here I'm going to tell you because I want you to grow. I already have my company. I'm doing numerous projects for HVAC oil and gas all over the world. I've traveled all over the world, and thanks to this profession, HVAC oil and gas, I've traveled all over the world. I've seen places I had been to, and whatever profession I am, or as a professional, whatever I've developed myself, apart from being technically strong, apart from being presenting myself to the client, or the way we need to use certain words, the meetings, and all how to conduct the meetings. Entire credit goes to this profession that is HVAC oil and gas sector. It makes a different professional altogether. Working in your own country and working outside your country is a hell of a difference. Your working culture changes, you meet a lot of people with different personalities, different culture, different ethics, different values, and you try to gel out and you understand and your vision becomes broader. So you should always, whenever you get a chance, always travel abroad, not just for money, but just to make yourself a better individual and better professional. That is my sincere advice to you. So we are going to begin this topic now. So just stay tuned because next slides is going to be the amazing one. So in the last slide, we saw that how important this sector is and what are the career opportunities and what could be and how you can grow in this career, or the what are the advantages of working in abroad apart from money. So in this today's just this slides, what I'm going to study about, what you're going to study about is nothing but how this particular sector is going to affect your career. Or when I say that marine offshore oil and gas, why it is different than others, or what is the future lying for you guys. You know, as the Prime Minister Narendra Modi has said, to me the blue whale of the chakra is a national flag representing the potential of a blue revolution or an ocean economy. That is how the central and ocean economy is to us. And the Forbes magazine says that Indian maritime industry is on the cusp of revolution. And there are several projects coming up in near future. That is Project Sagarmala, development of ports infrastructure, indigenous naval warships, oil and gas explorations, marine tourism, inland water transportation. So these are just few examples I'm giving within India. And when we go outside India, the opportunities are enormous. There are oil fields being explored in the Saudi Arabia. There are oil fields explored in UAE, Dubai, South Abu Dhabi. Then you have an oil field being explored in Qatar. It's a huge project coming up. So they need lots and lots of skilled manpower as well as the basic level and manpower they need to enter into the sector. So opportunities are humongous. All you need to is explore properly and tap it properly. So you need to be very smart enough to make yourself the way the professional you are. Again, there's a Russia, Azerbaijan. There are a lot of opportunities available. And then Southeast Asia, your Malaysia, your Indonesia. So there are opportunities available. Your opportunity in Thailand is there. There's oil exploration happening. Then plus there are FPSOs. We are going to see in the next one what FPSO is. So what I want to say that there are a lot of opportunities available. And in this basic module, which is going to explain the basics of the marine oil and gas HVAC, you will understand how to approach or how to gather the knowledge one by one to get step aside or to always have one step ahead of others because you want to because I'm going to tell you one thing, there is no substitute to hard work. Whatever apart from this course, you need to always keep on exploring the latest news, what is happening in the world about the oil and gas sector, upstream sector, downstream sector. You need to always be aware that which project is happening where. So you need to be aware of it. So this is going to affect you also. When I say oil and gas sector, do you think that you can launch a rocket ship on battery? No, right? The clothes what we are wearing, the table in front of you, the fiberglass table in front of you, the mouse, the calculator. You name almost 80% of your life is surrounded by the people where oil and gas has been used by even a fraction or up to the 70 or 80% of the composition. You cannot replace everything with a battery. No, you can replace the cars with battery. You may replace the trucks with battery. But what about the other things? You cannot replace with just battery. Okay, do you think that a cement plant can run on solar energy? No, it cannot because it has to use certain amount of it needs huge amount of power. So that cannot come just to the battery operated or solar operated plant or wind operated plant. No, every energy has certain limitations. So of course, oil and gas also has its own hazard and own limitations. So it is going to be a sustainable way we have to use it. We have to use it, but we have to use it in sustainable way. So this field is not going to go anywhere. This field will be there, and there's abundant amount of the oil and gas available in this earth. You might have heard in past also that okay by 2030 all resources will get exhausted, by 2020 all resources, but has it happened? No. Every day we are finding something new. So don't worry, there's huge amount of opportunity available in this sector to grow. There's a lack of skilled manpower unlike the other sectors. This industry needs the skilled manpower. So you are the right one for that if you prepare yourself and if you want to grow. But again, I say the hard work, there's no substitute to it. So if you want to do hard work, Do hard work. Anyway, you are doing the hard work. Anyway, you are doing the hard work. So do the hard work in this sector. Take extra effort. Try to learn. Ask us. We are there to help you. But there is no substitute to hard work because we have acquired this knowledge very hard way. There was nobody to tell us, but we learned. So our knowledge has a value. So I'm sure you will respect our value, knowledge, because the way we have spent our hard-earned efforts and all, definitely you'll understand that what important it is. That's why I'm passionate when I'm telling you. So definitely, it's big opportunity for you guys to think in that way and go into the oil and gas sector because this sector has lot of opportunities. So, what are the learning objectives in this curve, in this particular module, or in this particular basic module? So, in this particular module, which are going to cover the basics, I will go step by step, one by one, to explain you that what you are going to gain in this particular session. So this interesting session, you will be prepared to know or prepared to understand what I'm going to teach you. So let's go one by one that what I'm going to teach you, what you are going to learn in this particular session of the basics of marine HVAC and oil and gas systems. What I'm going to teach over here is some basic marine HVAC terminologies which are commonly used in industry. So you will be aware of the terminologies. So even if you are attending any of the interview pertaining to this session, or suppose if you say, sir, I have an interview next week for this sector and I just don't know anything. So this basic terminology also, even if you know, your chances will increase. So I'm going to cover the basic marine HVAC terminologies here. Second is applications of HVAC in marine sector. I'm going to cover that which, where and what type of equipment we need to use in marine sector. This is what I'm going to cover, or what are the applications, or you can understand also that when you say marine HVAC, how vast it is. So this point will help you in applications of the HVAC system in marine sector, so you can easily define that which system you can use it where. So again, it's not this particular model is the basic model, so I'm not going too deep into it. Unless you have the basic strong, you cannot go further. As you know, that you need to act, you need to sharpen your axe first. So sharpen your axe first over here. So applications are very important over here to understand. Next, I'm going to tell you about the major driving factors in marine HVAC design. Like every industrial sector, as every sector, if you see for wherever we are going to apply the HVAC, it may be residential sector, it may be a commercial sector where malls and other things are there or offices are there. Then again, there's a healthcare sector and the clean room sector and oil and gas sector. It's all together, or in the printing press also there's a different altogether HVAC system you have to use. So here in this particular applications, what are the major driving factors in marine HVAC? Also, I would be telling you in brief, so you will understand that why it is different from other sectors. Then I'm going to tell you about the equipment specification and metallurgy. Yes, you guys are smart enough to understand when I talk about these specifications, and you understand why I'm talking about it. Because I'm talking about ships, I'm going to talk about offshore, so you know the what kind of environment is around. It's all about salty environment. And it's a salty environment, what kind of material you need to choose, that I'm going to explain in this particular course. Again, metallurgy and the material selection plays very important role in marine oil and gas sector. And again, when I say equipment specification also, we need to discuss a lot about the hazardous areas, non-hazardous areas also in this particular basics. And without that, you cannot make a mark in this particular sector unless you know about the hazardous area, non-hazardous area, classification, what type of equipment we need to put into it. You cannot proceed further. So this is also very important chapter going to be in the next to next slides. So you need to be focused on what I'm telling you carefully. Then we are going to learn about the maintenance aspect. This is very interesting aspect. You will learn a lot about it. Why maintenance is very important in marine oil and gas. what are the limitations, constraints, what are the factors we need to consider over here. So this is also we are going to learn, and whatever the facts which I'm going to tell about the maintenance aspect is going to completely blow your mind. So listen also to this particular session very very carefully, because again what I'm going to tell you, you will not get anywhere in the internet, because this is very secretly kept sector, a very secretly hold sector. So just be patient, just be careful enough what I'm going to tell you. Yes, the maintenance aspect, just be smart enough to understand when I say maintenance aspect, why it is so important. Just start thinking about it. And anyway, I'm going to explain you. Then the next chapter, next topic which I'm going to cover is role and importance of standards. There are various standards, and standards plays very very important role in marine HVAC design, because standard becomes the part of the project, and sometimes client we have to follow a certain standard. It is mandatory to follow. Why it is mandatory to follow, that also will be followed in certain next sessions, so or next chapters. So I will explain each thing one by one. Please remember that this course would be more or less more of a theoretical in nature, because of course I will be covering the case study, that's a different status. And to do this course, I'm again telling you that you need to know the basics of HVAC. You need to know how to do the heat load calculations. If you don't know, go back and learn. Our courses are available for the heat load calculations, duct designing, pipe designing, everything. We have the courses. First, to complete those courses, if you have at least 2 to 3 years experience in this sector, then only this course is going to be useful. Because if you're expecting me to teach the heat load calculation in this particular course, it is not going to happen, because it's again super specialization I'm teaching you. And when I teach you super specialization, I expect you to know the basics, okay, of the HVAC, basics of this industry. Anyway, I'm going to teach you. But calculations and all, heat load calculation and all, I expect you to know, because when I'm going to present a case study, or when I'm going to give you to do certain examples, I expect you to perform the heat load calculations and then give me the assignments. So hope you what I'm trying to understand, what I'm trying to explain, you understand what I mean. And the question answer session also I'm going to cover it. So don't worry, this is going to be a full-fledged basic module. So I will make sure that you will have a complete overview of this particular sector. So whenever you want to make a career, just go through this course, religiously ask me the question. I'm here to answer the doubts whatever you have. Hello friends, this is Neeraj here, and in this particular model we are going to cover that marine HVAC and why it is so special. Yes, in this particular topic I am going to throw some light on why when I talk about the marine HVAC, then why it is so special. So first aspect I'm going to talk about the health and safety. Yes, you have heard it right. Health and safety is very very primary important factor for marine HVAC sector. When you go for any interview and if somebody is asking you that tell me why it is so special, you should know all these points, or at least you need to give one answer that first is safety is necessary, or safety comes, or safety ranking of the safety goes the highest when we talk about the marine HVAC system. And you will ask me, why, sir? Why you are rating the safety first instead of no? A person should need a comfortable environment. Person should need a humidity in control. Person should need a air draft in control. So why you are not ranking these things first, and instead of things, why you are ranking these things secondary, and why safety is so important? The answer lies within the question itself. Marine. Yes, when I say marine, you are in the middle of the sea, or middle of the river, or middle of the place where you are surrounded by the water. It is not the land. If something happens, you can easily go out of the building and keep yourself safe. It is between the sea. And again it's so safety plays a very very important role over here. So temperature, humidity, air draft, airflow, everything comes to secondary, and first thing is been safety. That's why I said health and safety. So safety plays very important role. That's why I said the safety is very important as as the first factor for marine safety as compared to the other, say industrial, residential sector or the commercial sector where it is built over the piece of land. So whatever happens, that your chances of survival are much higher as compared to the marine HVAC. So that's the reason the safety takes a first priority. Plus, again, the place where we have to work, say, suppose you're working on oil and gas platforms. So there are various hazardous gases being produced. So when you produce hazardous gases, again, you need to keep yourself safe from the gases. So again, for that also, the safety plays very important role in HVAC. So this is the safety, what I mean. When I say health, it is again to keep yourself safe from your health safe from the hazardous areas, not to have an impact on your health on hazardous area, hazardous gases. On the top of that, just to maintain the comfortable temperature within the accommodation and comfortable relative humidity conditions and airflows has to be proper in order to keep the person very healthy, and the top of that he should feel comfortable, because only thing or only time where the person comes to accommodation is to take the rest after he completes his duty for almost 12 hours. So when the person completes the duty and when he comes back to the accommodation, he should feel very comfortable. So again, it's a duty of HVAC engineer that whenever he's planning the things, planning the ducting, planning the design, he should ensure that a person who is inside should get a proper sleep within. He should be feeling good, energetic, and there is no sound buzzing or coming out of the diffusers. So this is what I mean about the health and safety. Now let's go to the next point, that is the operation and maintenance. When I say about the operation and maintenance, uh, in marine HVAC, we need to make a system which is very simple as compared to the other building sector. You know why I'm telling you that why it should be simple. When I say it's simple, it's not what I mean that do some ducting and no, it's not like that. When I say about the system should be less, it should be less complex, because more the complex system is, if something malfunction happens, you need to maintain more number of parts. The maintaining more number of parts is again more number of spares. And as you know that weight limitations of every ship has a weight bearing limitation. Again airport also, we have experienced on the aeroplane also, they limit your luggage of 30 kg up to 30 or 40 kg. So for the same reason. So even small weights also a matter when designing a ship. So again, the spare parts need to be kept limited. So lesser the complex system is, lesser the maintenance you need to do, and you need to perform and focus on the other aspects very carefully. So that's the purpose of operation and maintenance. Again, we are going to dive deep when I'm going to cover this session, or this is a separate topic I'm going to cover on operation and maintenance. As I told you, this field is a huge portion. You have a lot to learn. So I'm covering only basics over here. So when I say operation maintenance is what I mean is the thing, but uh, maintaining the system or operating the system has to be as less complex as possible. It should be as simple as possible. Then the third point goes about the codes and standards. Okay, codes and standards. When I talk about, there are various codes and standards. I will touch the base in the upcoming slide. So just focus. So without, I will not waste much my time on that. Logistics cost is the fourth point. When I say logistic cost, it means that is the cost which is required. If something fails, you need to bring that particular, you need to fill a requisition, and you need to bring that particular spare part or whatever part you need while you have a malfunction through the ship or some or for through the other ships, or through the plane or helicopter, whatever. So this is what I mean by the logistics cost. So again, it is going to be very expensive one if you don't plan your space properly. Just imagine you are in the middle of the ship, part of particular equipment fails, and you have not kept any spare, or you forgot to order the spare, or you have designed a system so complex that you give a criticality rating for that particular spare as 3 or 4. So, but it is important. So what happens here is that it is not simply you go out and buy and bring. It's not that easy. You're middle of the sea. Imagine how you are going to so easily out of the ship. You are going to swim, right? You're not going to jump from the sea, jump from the ship, and you're not going to swim. There has to be a system to be followed. First, you need to fill a requisition, it goes to the port, and they arrange it. So it's a hell lot of expenses because a lot of people, lot of systems get involved. So the spare part, which may cost you a $10 to $15, when it reaches you, it becomes $200 to $300. So again, it's a cost to company. It may be more than that also. This is just my imagine, just my wild thumb rule. So when you again design the system, you need to maintain. When you think of maintain the system, you need to think of the long-term basis of your maintain the spares also. I hope you got what I'm trying to say, and we are going to touch the base also in detailed course also, that how to think smart and how to save the money. Fourth is skilled, fifth is skilled and certified labor. When you work in the industry, again the skill plays very important role, and this skills doesn't come simply by no just by learning few things. You need to have basic very strong knowledge, and that comes only through a proper taking guidance from the proper people who are in the industry. Google is not everything. You need a mentor because mentor knows what it is. He only holds your hand and take you to the end. That is what we are sitting here to guide you properly and how to do it. So skilled and certified manpower and what kind of certification you need to take, and what skills you need to acquire to enter into this industry, and what skills are expected and what kind of work you are expected to do in this field. We are going to check this in the subsequent slides. So the next point is the construction features of HVAC equipment. As I've already covered in the previous slide, it works into the marine saline environment, and a salty atmosphere is there, a lot of humidity is around. So again, the material selection plays very important role here. So that also I'm going to cover in next slide. So be focused on that. Space constraint. Uh, yes, space constraint is the biggest hurdle in this industry. So how smartly you manage the space plays very important role here. You will get a very limited amount of space. In that, you need to plan your equipment properly, take out the ducting, take out the piping, take out the drain, plan your building services, potable water, everything you need to plan very carefully. And it, of course, when you plan, you need to be very confident on your data. So space constraint is the biggest thing you need to fight for with the architectural or piping department, because there the plot plan is in their scope. So this is very interesting going to be. And again, when I say space constraint, your duct sizes goes to upside down. You need to make a smaller duct. Smaller duct means more static pressure. More static pressure means everything changes. So you need to think in that particular angle also. The next point is engineering documentation. This is very important topic, engineering documentation, because whatever engineering you do, you need to document each and everything. Every value needs to have substantiation from where you have taken. You cannot, in this particular sector, you cannot simply take the value from air. Okay, just because you thought, or thumb rule. There's no rule of thumb rule in this particular field. You need to be very careful. You need to document. The reason for documentation is very simple. If something happens to ship or ship fails or something oil and gas platforms happens, that's why the documentation plays very important role over here, because it keeps your company safe. Because if every aspect is being documented, then insurance companies doesn't take any objection, because you have taken the values correctly, you have designed the system. So something happens to ship or oil and gas offshore platform, insurance department cannot pinpoint that certain things are not done. That's why your ship has failed or offshore platform has failed, because you have already given the basis of everything, basis of standards, which value from which table, which page number you have taken, and how your system design is happened, basis of design what you have taken. so you keep yourself safe. The next aspect is the insurance aspect, which I already covered that when you do the documentation, insurance doesn't take any issues normally. So from your side, you become safe over here. This is what and why the marine HVAC is so special. Of course, this is the basis and very very basic. And in the next subsequent chapters or next subsequent modules, you will dive very very deep into this particular course. And believe me, this experience is going to be wonderful because again, I'm repeating, you will not get anywhere in this industry or in this internet. Nowhere you will get that much kind of deep knowledge I'm going to share with you. So just stay focused because this when I'm teaching you very very interesting thing that it is a revision for me also. So it is helping me also in a way to refresh my basics or refresh my things. So it gives me altogether a different perspective. So in the next slide, let's see what's new for you to learn about. Okay, now when we talk about the HVAC system, what comes in our mind that there are certain expectation about this sector. And certainly, this is nothing wrong to keep any expectations. But when we keep expectations, we need to be very realistic also, and we should be aware that what the reality is. Okay, are you made up for this sector? Because each one is not made up for certain thing. Again, I'm telling you, if you are driving or if your mind is driving you to jump into this sector only for money, then don't come into this sector. If your aim is to come for money, if you want to aim is to come become a complete professional who has very strong fundamentals, very strong technical knowledge, who has very strong presentation skills, or who has very strong communication skills, you need to have very strong team management. If you want to learn all these things, plus you need to travel abroad. If you wish to travel abroad, you need to visit new places, you need to make new friends. If you make to have strong professional connections, if you want to grow globally, then only come into this sector. Otherwise, be stay happy in what you are doing. Come 9 to 5, go home. If that is what you want, then don't come into this sector. If you love challenges, if you love to learn new things, if you learn to explore the world, not just money. Money anyway you will get lot in this sector, but it's not easy money. I'm telling you. So if you are prepared to work hard, if you want to grow as a professional, then only come to this sector. So when I say expectations, in marine sector, you think that when you come, you will encounter with such a beautiful picture. Everything is rosy, everything is fine, and you are getting a lot of money and blah blah blah. But reality is a bit different. When you come to this sector, you are going to face a lot of challenges. Of course, what you are going to see in this particular slide is your reward, what you will get after working into this sector. But first, initial few years or initial 4 to 5 years, you need to really, really work very, very hard when you expect to grow into this career. And the reality of this sector is this. The reality says like this. Yes, you are right. You are the one which is in the photo, the man who is shouting, who is crying, who is screaming. This is how you are into this sector if you wish to enter. This is how you will be treated because all those hands, what you're going to see, are the hands of various other disciplines. Construction discipline, then commissioning discipline, then you have process discipline, you have piping discipline, you have the discipline for the safety, electrical discipline, instrument discipline. There are projects, management, then planner, all are going to come and they are going to jump on you because you are the main culprit in the oil and gas sector because you occupy lot of space, you consume lot of energy also. So everyone is going to look at you as a villain or sport spoiler, or everything is going to look at you as a spoiler. So that's why everyone will question you why you need this much space, why you need this much electrical energy. So you cannot keep quiet because keeping quiet is looked as a weakness. You need to have very very strong technical background, very very strong fundamentals. So that's why I'm telling you again and again. This field is not for the weak-hearted. If you are not weak-hearted, then only you come. If you are weak-heart, don't even dare to into this field, because first day itself, a consultant will tear you apart and throw into the four directions. That's what I'm telling you. You need good mentor to enter this industry. If you want to grow big, then only you think about it. This is a reality you need to face, and to show the reality is what I feel. What I feel is my duty, because I'm not unlike other courses. I will not tell you that. I will not give you the rosy picture of everything, and so that something, so that you my course you should view. No, it's not like that. I'm going to tell you about the warnings also. So if you are prepared for this, then only enter this field. Otherwise, don't enter. Hope my message is very, very loud and clear. So expectation is something good to have, but you need to face the reality of the situation also. So just judge yourself. Are you ready to take up the challenges? Are you ready to learn new things, or you just want a happy, go lucky life and without exploring some things? Then you take a call and wish to continue further. You continue. But I personally welcome you. If you're learning, I'm the first one who's going to welcome and teach you everything, whatever I know, I'm going to teach you. That's my promise. Okay, you might have seen that I am talking along for last 5 models. I spoke about the career scope of the marine HVAC sector. The career scope is a huge, as I explained. This is a very highly lucrative career, as I've explained you also in the previous slides or previous sections also. A person can get up to the 10 to 15,000 US dollars per month very very easily. The amount is up to around 8 to 9 lakhs. You can so understand this is amount is huge, or up to, it can go up to the 15 lakhs per month also. So 15 lakhs per month, 15 lakhs rupees per month is a huge amount for any engineer, or especially as you know, the marine HVAC engineer or HVAC engineer itself is 90% of the HVAC engineers are the mechanical engineers. So to get such a huge amount for mechanical engineer is very very rare. Software engineer we can understand. So we can understand that mechanical engineers also can get even a better pay than software engineers in this particular sector. So this is again I'm telling you it's a very very highly lucrative sector. So don't miss on this sector. If you are ready to take up the challenges, if we are ready to learn the new skills, if you are ready to take up the world, if you are ready to learn and make the new professional connections, this field is for you. You have opportunities to work abroad. As I've explained in earlier slides, there are a lot of projects happening. You need a lot of people over there. You have projects in Uzbekistan, you have projects in Russia, you have projects in Azerbaijan, you have projects in UAE, you have projects in Abu Dhabi, Dubai, Muscat, Kuwait, Saudi Arabia, Qatar. Again, you have some projects in, you can get an opportunity to work in USA also. In North Alaska slope also there are projects happening. So again, you have a scope to work in Norway side also, Sweden side also, because again there is offshore industry there. So from my experience, I can say that scope is huge over here in this industry, and you can work abroad and you can earn a decent amount of income to secure a family. Plus, you can grow as your career also. Excellent salaries I've already explained and already covered this topic. So again, the salary is a big thing. Professional growth also I've explained that how you can grow, since you have to interact with a very top five Fortune 100 consultants in the industry. You may take the name of the Qatar Gas, then you may take the name of the Qatar Energy, then there's a Ras Gas, ADNOC, then ENI is there, then Iran Oil Corporation is there, Petrobras is there from the Brazil. There are very, very highly skilled or very, very important top Fortune 500 clients. So when you work to that level, you as an engineer also grow. You as a professional grow. So that kind of different confidence comes inside you. And you become irreplaceable because you have that skill, you have that knowledge, you have that polishedness. You know how to handle any situation. And that not only helps in your professional life, it helps in your personal life also. You acquire a lot of soft skills knowingly or unknowingly. So working in abroad, working outside India always helps as a professional to grow. So this field helps you as an engineer because software you gets anyone can get opportunity. He has anyone from mechanical, chemical, anyone can go to the software industry and he can get that much salary. But if you don't want to go to the software industry, then what is the option to grow? If you are a mechanical engineer, again the option gets very limited. But this particular sector, marine oil and gas offshore sector, if you have knowledge in HVAC, if you jump into this sector, this particular sector shows you the path to grow, financially also and professionally also. Then grooming you as a highly competent HVAC professional because you keep yourself a different mark. When you stand with your counterparts or when you stand in along with the building engineers or when you stand with the commercial sector engineers, I don't want to make them feel low, but you yourself will understand that you very stand apart in terms of technical knowledge, in terms of the presentation skill, in terms of confidence. You will feel that you are far apart from your counterparts. Though it's a huge ocean, HVAC subject is a huge ocean, but you will understand that work you are doing and quality of work or the environment of the work or the nitty-gritties of the work, you as a HVAC engineer learn far better than the other sector engineers or other sector HVAC engineers. So this is also very interesting aspect and career scope in marine HVAC sector. In this particular slide, we are going to touch the base upon the major marine HVAC applications existing. When we talk about the marine HVAC applications, we talk about the marine, that is the ship also, and as well as the offshore platforms also. So when I say about the classification of the marine applications, here it is broadly gets classified. The classification of ship in types is like the ships for the transport of the cargo passengers, and there are other ships. The ships of the cargo passengers again gets divided into the multiple categories over here. There are some refrigerated cargo, recreation cargo. Recreation cargo consists of the cruise ships and sailor motor yachts, which the purpose is known to you. You know what is the cruise ships, you already know. That falls under the recreation one. Then refrigerated cargo are the one which carries all these fruits and vegetables and transport from one location to another location. Say for example, in the Gulf countries, there's a very limited amount of farming happens, so they need vegetables and fruits to feed the population over there. So what they do is they get a refrigerated cargo from all over the world, which travels past from their native country to the Gulf countries, and it has been offloaded, and the stuff contained in the refrigerated cargo has been taken out, and then it is thawed, and then the food is been served or the it in the supermarket. It has been kept, and people purchase it and make a food out of it. So that is how the refrigerated cargo is and use of refrigerated cargo in general. Then there are the bulk cargo ships which handle the crude carriers and the product carriers and chemical tankers over there. So they are normally called as a bulk cargo ships. Then there is roll-on, roll-off vessel. It is called as a ro-ro vessels. These are the type of ships which are the transport, which is involved in the cargo transport and the product transport also. There are other ships which are going to talk about. There are various other ships which are not related to the passengers or cargo, but this is related to the more commonly industrial applications kind of a thing. It can be a cable layer ship is there which lays down the cables. Then there's a fishing vessels are there. Then there are the vessels which are the sea cargo tugs and harbor tugs. These are some of the vessels for which, or some of the ships for which we needed air conditioning. Then there are the naval ships are there. There is aircraft carriers there, cruisers are there, destroyers are there, frigates are there, submarine is there. So mine sweepers are there. So mine sweepers. These are all things which also need air conditioning because the people are staying there. Plus, there are fishing vessels are there, and dredgers are there, cable layers are there. So these are some industrial kind of ships which we can talk about. There are some ice breaking ships are there. Then there's offshore platforms are there. It is seismic survey vessels. Then there's FPSOs are there. That is, we call it as a floating production, storage and offloading as a FPSO. So these are various kind of applications, and we have already covered in our previous module about this offshore platforms and how they look and what is the use of it and types of it. Already we have covered in the one of the lectures earlier. So these are the kind of classification in a broader way for the marine HVAC applications where you frequently or commonly use the air conditioning without which you cannot survive. So again, as I say that Earth is surrounded by 75% of the water, and to survive and to for their transportation from one place to another place happens to the ships. And when ship is there, HVAC is there. So again, this field is going to go rapidly in future also because there is no substitute. We all need to travel by water, whether you like it or not. So this is what it is all about. And we'll move to the next slide. Here we are going to talk about the important terminologies which you must know about this marine offshore oil and gas. When I say important, that means that if I'm talking about certain terminologies, you must be aware of what I'm talking. So you need to listen it very very carefully because this terminologies you will not get anywhere on the internet. So you need to focus it very very carefully. When I say a greenfield, what does the greenfield means? The greenfield means any project which you need to start by scratch is called as a greenfield, for which there is no information available. There you need to make certain assumptions. You need to have only a limited data available, and it's something like a new project. It is called as a greenfield project. For example, in a normal your life, if you want to take, suppose there is a project where you need to install a building. So you have only a site available for your building. So you can call it as a greenfield project because you have only site and you need to construct a building. And accordingly you start designing, okay, what is the soil quality and how much space available, and what is the architectural plan, how the construction will happen, what kind of cement I'm going to use, what kind of paint I'm going to use, how many floor story building I need to use, then how much water tank I need to supply, and how where the electrical lines will come, how much the load will be required. So these are all things which we plan and execute over there. So anything which is starting from the scratch, it is called as the greenfield. Then opposite to that term is called as a brownfield. The brownfield is nothing but a project which already exists but needs some modification. And when this modification is done, the capacity check or recheck needs to be done whether the existing modification, what we are doing it on the existing platform or existing structure, whether the structure is good enough to take care or strong enough to handle this new modification. Again, I am giving the example here of the building structure. You already have a building in place, and suppose your builder has additional FSI to build the two floors. So what he will do tomorrow onward itself, he will not go and construct two floors. First of all, he will hire an architect and he will tell, okay, I am installing the two floors, or I have to put the two floors above the 10 floors. So just check whether these two floors, whatever mass is coming, whether is it going to affect the load calculations, or building should not come down due to these two floors. And second thing, he will check that electrical, then your plumbing lines and all the water is sufficient enough to pump up to the two levels, and the residents who are going to come and stay there will not face any problem due to the capacity shortage or something which is for the existing building. So that additional study and putting the modification work comes under the brownfield. So hope you understand these two terminologies. It's very very important. One more terminology I forgot here to write, that is feed and pre-feed. Feed is nothing but FEED, feed, and pre-feed is nothing but PRE-FEED, pre-feed. These two are the studies, and the full form of this pre-feed and feed is, that is, feed is front front end engineering design. That is feed, front end engineering design. Pre-feed, again, a pre-front end engineering design. What does it mean? The pre-feed is carried out a high-level design, a very superficial thoughts have been put in what capacity the offshore platform or the structure should be approximately by thumb rule, what equipment we can use it over here, and how approximately the size of the platform is. So it arrives at the high-level budget for the management to sanction to start the project or start the feed work, which is goes into more into details. When the feed work is carried out, the purpose of the feed is very simple. Purpose of the feed is to bring all the EPC contractors on the common platform to bid it. And normally the feed is being carried out from a reputed consultants. They make the specifications, they make the initial drawings, they make the capacity calculations, and they arrive at a certain scheme. And when they arrive at certain scheme, uh, the drawings are attached to it, and then the same documents get distributed to the EPC contractor, and based on that they quote. So since all are on equal platform, equal level, there is no discrimination. And again, the system is also fixed, and HVAC requirement also fixed. So what happens here is there is equality over here, and client also get relaxed that money I am putting, and whatever outcome I will get, that will meet the purpose, and it will serve to the operators who are going to work on the platform. So that's the purpose of pre-feed and feed. Now let's go to the third term, that is vessel. What do I mean by vessel? Vessel is nothing but a ship, but in the technical language or maritime language we call it as a vessel. So please understand that when someone calls vessel, it's nothing but a ship in this, not your vessel which you use in your home. No. Fourth is a deckhead. See, deckhead is nothing but your roof. Roof we call it as a deckhead in the marine language or marine HVAC offshore language. So when someone says as a deckhead, that is, understand that it's a roof or a plate dividing the two levels. What is bulkhead? Bulkhead is nothing but a wall. A wall is named as a bulkhead. So in marine HVAC, bulkhead is nothing but a wall. Penetration sleeves. What is penetration sleeves is nothing but as per SOLAS, that is a Bible for any maritime standard. That is SOLAS, full form of SOLAS. Nobody knows. Even the good engineers also doesn't know about the full form of SOLAS. But I'm going to tell you, and you need to understand and remember it very well. SOLAS, that is SOLAS. SOLAS is a maritime standard. That is nothing but safety of life at sea. SOLAS. Okay. So you need to understand this. The SOLAS clearly defines that if any of the HVAC duct getting penetrated in the fire rated bulkhead, then if the size of that particular penetration is equal to or more than 750 square centimeter, how much? 750 square centimeter. If it is more than that, then that particular bulkhead, that is wall, which is made up of steel normally, has to be provided with minimum 3 mm thick mild steel, that is MS sleeve, which is 900 mm long. How much? 900 mm long. It could be 200 or 700 or 450 on either side of the bulkhead, but the length should be 900 mm long. So this is what is called as a penetration sleeve. And again, this side of the sleeve, again you can continue with the ducting. This side of the sleeve, again continue with the ducting. Since it is penetrating the fire rated bulkhead, we need to install the penetration sleeve. So this is also very common question we should be able to remember. What is cowl with a bird screen? Cowl with a bird screen is nothing but if the penetration is happening, you will find that a 45-degree cowl is been given and there is a bird screen given. The reason for that is the cowl is that suppose the rain is happening, the water should not go inside the duct or the opening, which is either exhaust or fresher ducting. So either it should not go into the fresher or it should not go to the exhaust. That's the purpose of the 45-degree angle provided. And there's a bird screen because birds should not enter inside and should cause any accident. So that is the purpose of the cowl with the bird screen. Normally cowls with the bird screens are provided at the intake or an exhaust of an HVAC openings, for the air duct or the intake or exhaust for the HVAC openings, or even the fresh air intake or natural intake, whatever you call. Next is fire rated bulkhead. This terminology I will be explaining in the deep next course module. But as the name indicates, fire rated bulkheads are classified in various ways: A0, A30, A60. So there are various classifications of the steel bulkhead with the insulation. So that I will be covering in the subsequent slides, subsequent part of the course. Wall panel is nothing but suppose there's a ship. So in the ship you need to stay. So you need to stay in the accommodation. So when you're staying in the accommodation, definitely you would not like to see the steel around you, right? There should be a room with good architectural finishes. So wall panel helps in that. Wall panel is installed on the top of your steel bulkhead after the insulation. So there's a steel bulkhead, insulation, and the wall panel. This kind of arrangement normally is there, and they have been kept together by stiffening. So this wall panel acts as a architectural finish for you. What is galley? Galley is nothing but a kitchen. In a common man terminology in the marine HVAC, a kitchen is named as a galley, and there's a very deep topic I'll be covering about the galley in subsequent sessions of the marine oil and gas session. So galley is nothing but a kitchen in simple language. So someone calls galley, galley is nothing but a kitchen. Remember this so that in interview you can very well clear it. Okay, what is bridge deck? Bridge deck or wheelhouse is nothing but a place where the captain of the ship is staying. So he's handling the ship from there. There's a wheel there, and all you can see the gadgets there. Electronic gadgets are there in kept. So from this place, the entire control of the ship is happening. Again, there is a separate standard over in the marine oil and gas that we'll be covering in the subsequent session. Then what is port? Port is in the terminology when we talk about the marine HVAC or the marine system, port side of the ship. When someone says that check the equipment to be kept, HVAC equipment to be kept on the port side of the ship. What does it mean? It means that suppose you're standing on the ship and you're standing and you can see the front side of the ship. There are two sides, one is front side, one is back side. So suppose your eyes are at the front side of the ship. Okay, you are on the ship and you are looking at the front side of the ship. The left hand side is called as port side. Left hand side is called as a port side, and the right hand side of the ship is called as a starboard side. If you are looking toward the forward of the ship by standing on the ship. Hope you understood it. And the back side is referred as the aft side. Aft side. So this right hand side is starboard side, and your left hand side is going to be your port side. This is forward side, and this is aft side. Back side is the aft side. Then the dry provision store is nothing but there are certain dry items there also there, like the your coffee mixer, coffee is there, sugar is there, tea is there. So these kind of items are kept in a dry provision store. That is also part of the chiller freezer system, which we are going to cover it in the subsequent topics. Also, though in this session we are going to touch the basics of the chiller freezer system, but as we go deeper, we'll cover it in the next sessions. Now let's go to next sessions. Now when we talk about the typical HVAC design objectives, here are the typical design objectives which you commonly should remember. So question may come in the interview that what are the typical HVAC design objectives for the marine sector. So the answer to what you need to give is this. That is maintain the temperature in RH for a particular requirement as per the codes and standards. Second is the maintaining pressurization between hazardous and non-hazardous areas. Then third is the applying ventilation for occupants and removal of the toxic gases. Then the fourth one is arresting the dust and contamination by filtration. Fifth is vibration and sound control. And the last one is the drain management. As I told you, safety is one of the important aspects. Here also safety also plays very major roles. When I say the pressurization maintenance is a part again of the safety. So first is again the safety is important, then maintain the temperature is also important, then dust arrestance of the dust and contamination also is important, removal of hazardous gas is important. So these are the basic of design objectives of the marine sectors which you should remember, and we'll move on to the next slide now. The next slide talks about the typical HVAC operational objective of the marine sector. In the last slide, we checked about the design aspects. In the design, what we need to take care, like safety and the temperature and the RH and sound level and vibration, drain management and pressurization, all these things. Here in this slide, we are going to cover the typical HVAC operational objectives, because design objective is one part and operational objective is another part. So in operational objective, if you see, the HVAC equipment must be in continuous operation. Any guesses why it should be in continuous operation? Any doubt? Well, it should be in continuous operation because there is a continuous occupancy always happens in the LQ. LQ is nothing but a living quarter. That is the place where people come and stay. So equipment has to be a duty and standby arrangement. So it always runs 24/7. Second is redundancy. Redundancy of the HVAC equipment serving the critical areas. The reason is that suppose something happens, the duty and standby. Suppose only one equipment you are providing, and suppose one fan you are providing for the smoking zone. Suppose only one fan is providing for the kitchen. Something happens to the fan, just imagine what will happen. Person will start feeling uncomfortable. Pressurization you will lose. There is always a danger of hazardous gases coming inside the accommodation. So for the critical areas, always the redundancy is must. Third point is the power supply from the dual source for the critical areas of the HVAC equipment. That is main power supply plus emergency power supply. When I say this, what happens over here? Why I say like that? Just imagine the staircase which is inside the LQ. In case of fire happens, HVAC system gets shut down because that is a major again the source of the spreading again the fire, because they are supplying the oxygen with it in a large quantity, and of course the fire is happening, nobody is going to stay there, so what's the point in starting the HVAC over there? So still, but you have a staircase over there and you need to pressurize it. Just imagine the main power source is off, then you need to provide the emergency power source to the staircase pressurization fan. So we need to identify which are the areas which are critical like this, and we need to plan our power source as per that. So this is for the HVAC to plan the emergency power also. The emergency situation, always discussions happen with the technical safety department. Types of department also I will come in the next slide or the next session. But for time being, you need to understand that we need to think of the power supply from the dual source also for the critical areas. Don't worry, this is not everything. If on each and every point I can talk about 10 days or 15 days. That's what vast subject it is. So don't worry, this is just a basic. So I'm going to come anyway with the very huge volume of the things. This is just a basic. So just I'm focusing on the very important aspects. Then the dust and contamination filtration is also very important over here. Then operational simplicity, critical spares and interchangeability. These are the very important aspects over here. When I say operational simplicity, it's nothing but when we are starting in a system, it should not be complex. It should be very simple to operate, because more the complex system, more the spare parts are needed. More the spare part you are using, more your logistics cost will increase, your weight will increase. So system should be as simple as possible, but yet it should be an effective one. Critical spares is also the same one, because you should not increase the weight on the ship or you should not increase the weight on the platform. The spares has to be ordered in a limited quantity. That is also the spares of a critical parts only, not for everything. Then interchangeability is something, try to select the AHU model or AHU motor model, fan model, or ventilation fan model as similar and close to each other, because something failure happens to one, the spare parts is only common. So you don't have to buy a different capacity motor, because if one spare is there, you can easily interchange with each other. So try to standardize the requirement as soon as possible by being flexible in the design. So this is what the purpose of I am talking about the interchangeability. Now let's move on to the next slide. Here the other important aspects are also equally important to understand. What does it mean? So let's look at it one by one to understand the importance of it. The blast rating. The blast rating is nothing but it's a blast rating of the bulkhead. When we say blast rating, this particular study has been conducted by the technical safety department. When they conduct a study, they analyze that there is a living quarter over here where people are going to stay, and there is a process platform is over there where you are injecting an oil over there. So, or removing the oil from the well. Just imagine that during this process, suppose a blast happens, then what will be the impact on the accommodation walls where the people are staying? Not only accommodation, it has to calculate the impact on the overall surrounding areas also, how it gets impacted. As you might have seen in movies, a blast happens, you will start that everyone is flying around and is being thrown at the large distance. It means that when the blast happens, there is a huge amount of compressed sound wave get generated. And it when the sound waves get generated, it gets converted into the pressure in form of a pressure. So the pressure gets created in the air, through that the people gets thrown away. So, when the blast happens, similar impact may take place over the accommodation and people will get impacted. So, when the study is concluded and when technical department says or technical safety department says that due to wall there is a danger to accommodation, in that case, wherever there are the openings of either fresh air or there is exhaust, it is recommended to provide the blast rated walls or blast rated dampers. If you Google it out, you will understand what I mean. It's a mechanical damper which is blast rated, and we need to give the blast rating to the equipment manufacturer. There are very few equipment manufacturers, or there will be few damper manufacturers over there who produce the blast rated dampers. Normally the length of those dampers is almost 1 meter, so that they can mount all the arrangements, and there's a spring over there which can sense the sound pressure and it closes automatically after achieving that pressure. And this is what the dampers are made up of. So this is what the blast rating, and I'm going to cover it much into detail in the later section how it looks and all. Then the workplace sound level limit. In accommodation also, if the person's tired and he's going to come and sleep, definitely he would like to sleep in a proper manner. He doesn't want to have a very noisy sound around his cabins because he's already tired. So every standard, if you see, there is a certain level of noise level which has already been stated. Say for example, North South, that is North Sea standard, the sound level is specified at 35 dBA, which is very very stringent. So they frequently use the sound attenuators everywhere. For the other applications, somewhere in 45 is there, somewhere 55 is there. So it varies from standard to standard which we are following. So this is what the workplace sound limit is also very important aspect while designing the HVAC system. And we need to follow whatever is mentioned in standard. Then it goes to noise and vibration consultant and he verifies whether the sound attenuator is needed. If needed, then which location it's needed. And this also report we are going to cover in subsequent session. Yes, I'm going to tell you about that report also, how it looks and all. Then let's come to the corrosion resistance. What is corrosion resistance is nothing but it is a material selection which we need to do for the offshore. This we have already covered briefly in the previous chapters, that since the atmosphere within the sea or within it's very salty, so it affects the material selection also. So as far as possible, the critical equipment which are mounted outdoor, as far as possible, it should be either marine painted for and tested for a long time, or at least for 300 hours continuous salt bath it should be given, or tested for it, marine painted, or it should be a stainless steel one. Now let's come to the static electricity discharge. This point is very important because as the relative humidity in the surface drops below 30%, the static electricity gets generated over the surface of the equipment. You might have seen that in this harsh winter, if you're gone and if you're touching any metallic object, you will get a static electricity current. The reason is that static electricity gets deposited in the extreme dry environment, and that can play a havoc if not been done the earthing properly. So static electricity discharge is also very important factor while designing the system. Wind direction plays a major role. As you know, being an offshore or being into the sea, the wind velocity is very high as compared to the land. And as you venture inside the sea, you need to check the wind direction. And ships we cannot control where the inlet and outlet of the fan we should keep. So we normally keep the static pressure bit high than the required to cope up with the wind pressure. But for offshore we can plan. For offshore sector we know the wind platform direction. We know the platform direction where we are going to keep the platform. So prevailing wind direction we can easily find out from the meteorological data. So as far as possible, we should avoid keeping our inlet or outlet opposite to the wind direction. Or if it is unavoidable, then we need to have some cowl so which should protect against the wind pressure. Then the penetration, which I've already covered, so I'm not repeating again what the penetration is. Then next part is the plant room layout is also very essential. As I've already told you that the space constraint is very huge in accommodation platforms. So plant room layout has to be as optimized as possible so that we can keep all our equipment inside and still we can manage well within. Again, we need to cover the space constraint. As I told you, that it's the biggest headache and biggest challenge for HVAC. Space what we get is very limited inside the accommodation platform. So we need to really good, very good in space planning. Not only space planning, but we need to take care of the material maintenance requirement also. Because in case of requirement of maintenance, how we are going to handle it. Suppose you have to remove the part and take it out, whether enough space is there to take out to the door. That kind of minute study we have to do with hand in hand with a mechanical discipline, which handles the material handling report. Then there is a zone wise area classification. This is a bit detailed and a deep topic, so I won't be covering it now. So let us keep it at the subsequent module. But this is the one of the very important chapter without which you cannot say you are completely an offshore oil and gas professional unless you know the zone area classification, what I mean about it. It is zone 1, zone 2, zone 0 and all. Lot of complex things are there, gas groups are there. So this I will be covering later on. Which equipment to be selected for what and all. This is all classification. I will cover it in the subsequent lectures. Then there are MCTs, that is multi-cable transits. Multi-cable transits are nothing but suppose your cables which are passing through the bulkhead, that is wall, the steel bulkhead. So you cannot simply puncture and take it out in the bulkhead because you need to seal it also. So for that what happens, there is a MCTs comes. The picture of the MCTs, everything I will show it in subsequent lecture. But through a frame and there's only a frame with a lot of holes of the similar dia which we are going to pass and design. So through that all the cables go inside the accommodation, and these are the fire-proof arrangement also has been done to the MCTs. So this is what we call as MCTs, and this is also very important factor and the motor thermistors and the heat tracing. This is also one very important aspect you need to consider while designing the HVAC system for the offshore oil and gas and marine sector. When I say motor thermistors, there are areas or there are zones in the world where oil and gas extraction happens. Say, for example, in the Norway, Sweden, Russia, where temperature drops down to minus 35, minus 20. So, in this case, what happens? The motor, which is at the standby mode, the winding gets completely freezed. So winding should not get completely freeze, and when it should start properly. So to keep it heated basically up to certain level, the motor crankcase should get heated up to certain level for the fan and HU. There is a thermistor being provided for the all the motors above 2 kilowatt. That's the standard for as per the NORSOM. So when it is been provided, it keeps the warm, it keeps some warm. And so this particular load also we need to give it to the electrical discipline so they can incorporate in their load list requirement because they need to provide the DG set for the requirement. And let us talk about the heat tracing. Similarly, you have a drain which is coming out, but as you know, the temperature itself is minus 35, minus 20. So all ice gets formed when the drain happens. So for that, the heat tracing is been done. The heat tracing is nothing but a heating of your drain pipe. It may be in chiller phaser room or it may be normal AHU room. So of course in the winter your AHU won't run. But suppose imagine there is a static water inside the drain. It gets freeze and it may create a block. So in the chiller freezer room, of course, you have a minus 34 degree, minus 24 or minus 30 degree, irrespective of outdoor conditions. Even being the 40 feet to 50 degrees, still you have to keep it because you have your food inside. So for that also the heat tracing is being done. Now let's move on to the next slide and see what is in the next slide. Now this particular slide talks about the HVAC equipment selection aspect. Well, when we say HVAC selection, of course, I'm talking about the equipment or the accessories or the components which we require to select. Say, for example, let us take example of air handling unit. As I told you, the internal air handling unit can be kept internal, air handling unit can be kept external also. But when we think of the material or the air handling unit location, we need to always think of a long term. And keeping the air handling unit external should be the last option we should think of. The reason is that whenever we install any equipment on offshore platform, we need to think of the life or longevity of the equipment. It should go because to replace equipment is going to cost almost equal or more than the cost of an equipment. So the longer the equipment runs, better it is. So it is always advised to have an AHU inside the enclosed space because if its AHU is kept outside as per certain standards like a Shell DEP, if the AHU or any fan is outside, irrespective of the hazardous area is there or not, we have to keep or we have to maintain it as or we have to this particular it has to be certified for the zone 1. So this is also very critical aspect as far as the costing is also concerned. So better to have an enclosed room and have it inside the room on safer side. If it goes inside, your material becomes a GI. If it goes outside, your material becomes a SS. So again, the cost difference is also substantial. So better to have it inside. And when it is inside, the coil material has to be a copper aluminum. If it is outside, it has to be a copper with a Harrisite coating. Harrisite coating is a coating which protects the cooling coil and the fins from the corrosion because the fins are copper aluminum, still they are susceptible to the corrosion due to saline environment outside. Then let us talk about the chiller. Chillers are normally two, that is water cooled and air cooled. Normally air cooled chillers are avoided. The reason is simple. The reason is that air cooled, as you know, acquires more footprint as compared to water cooled. So water cooled is being given first option. But in case the water cooled facility is not available, say for example there are standalone platforms. There are platforms which doesn't have an accommodation. It consists of only electrical room. So in that case, water provision is not there because there is no water required for anything. So in that case, the last option prevails is the air cooled system. So in that case, they go with for large capacity air cooled chiller, or mostly they see that air cooled condensing unit and the AHU arrangement is provided. If you are not aware of what I am talking about, the chiller air cooled condensing unit, then I suggest that first you complete our course, basics course, in that all equipments have been elaborated. So understand what the equipments are. Then you come to do this course. But for this course, the preliminary recommendation is that you should need to have at least 2 to 3 years experience in HVAC field. Then only you will understand what I am trying to say. Because in this particular course we are not going to start the designing of heat load and all. I am not going to teach you because I expect you that you know it already. The third aspect is again the air cooled condensing unit, which is again kept externally being air cooled. We cannot keep in the room. So again it has to be copper with hydroxide coating fins, and some standards specify that the body also has to be stainless steel also, or SS316L. So it depends on standard to standard and the client to client, specification to specification, it changes. So whichever project you are working, you need to make sure that tender documents you should read it thoroughly. Because for oil and gas project, when it's awarded, the tender documents comes in a huge quantity. They are huge, so you need to study it very carefully and check not only technical but techno commercial aspect also, which can affect your budget. In the ventilation fans, also normally preferred as tube axial fans. Fire dampers, again there are various types of fire dampers. So those fire damper types, I will cover it up in the subsequent lectures because it's a very important one of the components, and it cannot be covered in 1 or 2 minutes. It's a huge session required for that. So I will cover it up in the next subsequent sessions. Then volume control dampers we are aware of. Normally in oil and gas sector, the heavy duty volume control dampers are used. The thickness of the volume control dampers is normally more. It's normally 2 to 3 mm we keep due to offshore requirement. Then there are air terminal units. Air terminal units also you have diffusers, you have grills. Then you have the sound attenuated plenum boxes to minimize the sound levels. So though these all things I will cover up in subsequent lectures. Then there's the E&I VFD panels for the HVAC, that is electrical instrumentation requirement, variable frequency drive requirement for the HVAC, then piping ducting requirement also changes from project to project, client to client specifications. Of course, what are the specifications I will be covering up in subsequent, because these are the basics, so I'm covering only the basic aspects of it. So hope you liked it. So let's go to the next slide. Now let's move on to the new slide. Roles and classification of the standard. Well, we can talk very much detail about the rule and classification standard because this is very important topic again. Because as I already told you that when the project comes, we need to follow a certain standard which is defined by a client, or the type of ship or type of the offshore platform it is. We need to follow certain classification standard because the approval engineer comes from this body, and he class engineer comes and he checks your all the drawings and construction and gives you the approval that you have done the work as per the standard. So without that you won't get the certification, and unless you get the certification, your insurance and all doesn't have any value. So there are certain bodies over there. There is International Association of Classification Body. It is ISCS, then ABS, that is American Bureau of Shipping is there. Then RENA is there, that is Royal Institute of Naval Architects. SOLAS is again very important standard. NORSOC is again important standard. DNV is important standard. BV is there. IR class is there. So these are the some standards which I will be covering in subsequent session. But just to have an idea, this is what the standards which we need to be aware of while designing the HVAC system. For marine HVAC, some of the ISO standards also which are commonly being used. So what are those standards? Let's have a look at it. First is ISO 7547 for living quarters on the ships or vessels. So suppose we have to design the FPSO, suppose you have to design the passenger ship, suppose you have to design the cruise, then this is very important standard. It is ISO 7547, which talks about even the pressure requirement, how much it should be minimum as compared to the total air supply. Then it talks about the minimum number of air changes in the toilet, in the galley, or in the laundry, or in smoking area, recreation area. And it talks about if at the initial stages, suppose the heat dissipation values are not given, and it gives some indication towards the heat dissipation values also. And again, it gives a dissipation of the U value of the bulkhead and deckhead. It gives an indications about the reflectivity index. There are a lot of things which has been covered inside this standard. So this is also very important standard, ISO 7547. And it is followed by the next standard, that is ISO 8861. It gives how to calculate the engine room ventilation. I will be sharing you the calculation sheet format in subsequent lecture, and you will understand how we can calculate the engine room ventilation size of a fan for engine room. So this particular standard also plays very important role to understand how the engine room ventilation calculation has to be done. Because when you say engine room, the ship has an engine room which has a propeller, alternator, so ship should move forward due to thrust. So there's an engine room which is normally a diesel engine, and the size of this engine is very huge. So for that, ventilation is a must. Same for the diesel generator also. This 8861 can be used in the offshore platform. Then let's talk about the 8862 is for the control room. How much should be the heat dissipation and how the ducting should be done, that is decided in this particular standard. Then there is the standard 8864 for the wheelhouse. This standard talks about the requirement of the air conditioning in the wheelhouse, where mainly the captain is sitting of the ship. For offshore platform, there is no wheelhouse, so it is only for because it's a fixed platform. But for the ship's wheelhouse is mandatory. There is normally the captain operates the ship by sitting there, and his crew, so, which is helping him, they take a call. Then ISO 9099 is for the galley. Galley is nothing but a kitchen. This is very important chapter, a very important thing which I will be covering in subsequent lectures. For galley, what happens is uh, your system supply exhaust is been designed based on the heat dissipation from the galley equipment. And again, they work on cycle. As you know, the galley equipment doesn't are not 24 by 7 working. So there are certain shifts, that is morning breakfast, and then there's a afternoon, and there's a evening. So only in the three shifts the galley is operating. So when the galley is operating, there's a heat dissipation happening from the fryers, heat dissipation is happening from the burners. So all these things we need to consider while designing the galley, and that much heat dissipation. If not given, then certain amount of value is given in the standard which we need to follow. Then let's talk about the dry provision store is 9943. As we have already covered, it is a storage where the material which is not required to be specifically at low temperature is being kept, like sauce is there, and condensed milk is there, then the dry fruits are there. These are certain things, cheese of certain degree. So all these things, dry cheese normally we call, it is being kept at the dry provision store. The ISO 15138 is basically more of an HVAC requirement for the offshore platform specifically. So it covers all the requirement of the safety, then temporary refuge, and interfaces with the other discipline, interfaces with the technical safety, interfaces with instrumentation, type of ducting, material ducting, velocity to be considered, sound level to be considered. These are some of the details which are covered in ISO 15138. which would be looking in deep in a subsequent chapter. Now let's move on to the next chapter and see what it is. Uh, this is again a very important slide I want to talk about. This is a typical GA layout of the living quarter or where the people stay. Again, I say this is a typical one. That doesn't mean that every platform or every ship has to have such kind of a layout. Layout differs from the client to client and requirement of the client, but this is what typically how it looks. Or these are the typical rooms. It could be more rooms also, but as I say, it's a typical one. The deeper one I'm going to dive in the subsequent sessions. Being a basic one, this is what the layout it looks like. If you see on the right hand side over here, this is what the cabins look like. These are all the cabins and these are the lockers, these are the beds where people come and stay. Normally there are two shifts. So one first shift, morning shift happens, this person goes for the a person goes for the work and the second person comes out after his shift finishes. So it works 24 by 7. And these are, if you see, this is a common washroom over here, and common lockers are there, and common washrooms are there at this corner and this corner. And again, I'm saying it should not be necessarily the same one. This platform is having this arrangement. Most of the times, your bathrooms and washrooms are located inside the cabin itself. Again, on this level, if you see, there's a mess room, there's a kitchen, there's a recreation room over here where gym equipment are kept. There are lockers, there are smoking rooms here over here. So such kind of arrangement also. There's electrical room. So such kind of an arrangement also is existing in some of the platforms. Platforms can be a 2-level platform, 3-level platform, up to the 5 to 6 level platforms also are available based on requirement and the design of the system. So now let's move on to the next slide. Next slide covers the basic images of the equipment. This is again I am going to cover it in subsequent next chapter. So again, just to give the idea when I say about the images of equipment what I talk about. If you see, this is a fan with a motor, and motor is a bifurcated type. What I say bifurcated type is the motor is not exposed to the airstream or the exhaust which is coming from the kitchen. The reason is of course the simple. The exhaust or the airflow which is coming out of the kitchen consists of the say grease or oily fumes which may get deposited over the motor body, and oil being an hazardous and gas a fire friendly material, it is not at all advisable to get deposited over the motor body. So in case of sparking happens, it could be a disaster. And as I already told earlier, the safety is a very important factor for marine oil and gas and shipping sector. So that's why such kind of an arrangement happens for the galley fan, where it's a bifurcated type and motor is kept outside the airstream. Such kind of details you will not get anywhere in the any course which I am presenting over here. So listen it very carefully. Bifurcated motors are used for the galley exhaust. This is what the typical hood looks like. This is what the fryer or the burners are here, and this is the exhaust capture hood over there which is made up of stainless steel. Interesting fact is that whichever equipment you are using inside the galley are mandatory has to be a stainless steel one for the obvious reasons. See, this is a mushroom cowl over here, and this is what is the penetration looks like. This is a fan over here, and the exhaust air comes out from here, or even the fresh air gets sucked from here based on the requirement. If you see, this is a vertical AHU with a plenum arrangement. It has been done basically where the space constraint or the room is very small. Such kind of arrangement is preferred. But again, such kind of arrangement has the limitations on the static pressure. So it has been seen that when any of the AHU has been proposed like this, the platform is normally a smaller duct length. or in terms of lengths. This is what, due to space constraint, we have to sometimes do some certain adjustment to fit our equipment inside the room. Again, these are the basic photos. I would be covering the deeper one later on in the subsequent session. For the time being, this session is just to give the ideas about the type of equipment typically used for the offshore industry. Now let's move on to the next slide. The next slide, basically we are going to talk about the single line diagram for marine chiller freezer room plant. Again, this is a basic one, so I'm not going too much into the detail. But as you could see, this is going to be a seawater cooled condensing unit with a compressors over here if you see, and the respective indoor units are being kept at the respective rooms. So typically if you see, there are three rooms over here. It's pre-storage room, chiller room and a freezer room. When we talk about these three rooms, we need to understand that in this room the storage of either fish, meat, fruits and vegetable do happen. Now let's take an example of pre-storage room. When any frozen container from the shore comes inside, it doesn't need to directly go into the chiller freezer room. So some of the material has been kept in a pre-storage room at plus 17 degrees Celsius, and the freezer room is required to be kept at minus 20 to minus 24 degrees Celsius, and freezer room is kept at a plus 2 degrees Celsius. Normally freezer room contains the vegetables and fruits, and the freezer contains normally the meat and fish. And the calculation and the heat load values and all I would be covering in a subsequent sessions after a while. So just be focusing, because there's altogether a different chapter will be there. But as you could see very carefully over here, all these pipes and single line diagram I have shown, and I would be explaining it later also. But for time being, if you see what are the walls being installed, you will understand the basic schematic diagram over here. See, there are accumulators are there, the oil separator is there, then there's a LP-HP switch is there, then there are gauges are over to understand the conditions inside, to analyze it, and there is, if you see, there's a non-written wall over here. All the purpose of this, all the walls, I will cover it in subsequent session. And there's a TXV is there, there is thermostatic expansion wall, how it operates. I'm going to cover it in subsequent session. So just to give an understanding, this is how it looks, and this is how the arrangement it is. There's a separate room always been provided to house these units inside. So this is what all about the chiller freezer plant room looks like for the marine HVAC system and often the offshore systems. And these are the subsequent lines, that is all this all you can call it as a suction line and the liquid line. And suction line and liquid line, suction line is nothing, liquid line is suction line is nothing but the line which connects from the evaporator to the compressor is suction line, and liquid line is nothing but the line which goes out from the condenser to the evaporator is a liquid line. So these are the two kind of lines normally it has been covered. So now let's move on to the next slide. A battery room is very important aspect as far as the marine offshore oil and gas is considered. The battery room basically consists of the batteries which are normally UPS. For the UPS system, the batteries play a very important role to have an uninterrupted power. So the batteries always need to be charged, and when the battery charging is required, it releases certain amount of hydrogen, and hydrogen is a hazardous gas. This entire battery room calculation along with the example, I would be covering it in subsequent session also. But for time being, to understand what the battery room and how the normally ventilation happens, this is a formula as per the EN 50272-3 is been considered over here. and we need to gather the sufficient data from the electrical department to start with. So they when once they give the data, we do our calculations. So since the hydrogen is getting released, hydrogen gas is always a lighter in nature, so it gets accumulated over the ceiling. And for that we need to provide uh, for that we need to provide the fans which are duty standby suitable for hazardous areas, and the ducting always goes at the roof side, roof type. It touches the roof, and the suction happens from the side or from the bottom. So it takes care of the hydrogen gas which is getting accumulated at the top. And when we talk about the requirement of the air conditioned room, air conditioned air, when we supply to this battery room, it is always supplied at the floor level. So a draft effect should happen. So gas should get pushed to the level above the ceiling. So that is a requirement. So ideally it should get sucked properly. And if you see this formula carefully, this is a formula which has been applied to calculate the ventilation rate to take out the hazardous gas outside. But again, there is a one more thing over here. Normally, this or 12 air changes, which is standard industrial practice, whichever is higher, is taken into consideration while designing the battery room system. In battery room being a hazardous areas, any electrical equipment which is kept inside, say for example fan or panel, you need to consider that the fan has to be suitable for zone 1, gas group 2C, temperature class T3. So this is again I'm going to cover up in details. So fan cost also significantly is higher in the battery room, and the details I will cover up in subsequent session. There is a case study over here which I would wish to cover over here. This is a standalone platform. This is not a LQ platform, and if you see, this is a room over here, and this is the length of the room. I think it's close to around 8 meters by 3 to 4 meters over here. This is the electrical room, and normally you would be wondered that this is a very small room, and even a window AC can do the job. But window AC is strictly forbidden in offshore applications because it doesn't create any pressurization. It works on simply the recirculation principle. So you must be wondering that what kind of HVAC system is proposed over here. So for this particular room to be air conditioned, it is preferred to have or considering the space requirement over here, the air cooled package unit is proposed for this particular room to supply the air, because it should create a pressurization also inside, and package unit can create a pressurization very effectively. So by means of supply air being supplied and require amount of pressure with the ducting arrangement and balancing, it can be achieved. Now let's see how it can be done, and that I have covered in subsequent slide, and you will explain that how it's been done and how it looks like. If you see, this is a typical arrangement. If you see, this is a package unit over here. There are two fans over here, a filter arrangement, and one fresh air intake is there with dampers and lot of controls. If you see inside the room also, there are a lot of controls. There are dampers, left, right, and center. There's a pressure lift damper, and there's a energen damper. What these dampers are all, I will cover up in some separate sections. But purpose of showing this case study is very simple. That for a small simple room, if you see, there's so much of controls over here. So much of controls, so many dampers are there. So much of ducting arrangement is there. No, so much of the footprint has been utilized to keep the room. So this is not as simple as it looks. The HVAC oil and gas sector, it is very complex. That's why I have shown it to you that why it is so difficult. So you should understand that when I say oil and gas offshore sector, you will understand that I am talking about a different animal over here. So this is how complex it is, and this all P and ID I will discuss in detail in when I tell you the details in the course I'm going to discuss. Case study we'll discuss one by one, and we'll check the calculations also how it is being done. So this is end of this slide, which can give you the basic idea of the system, of even the simplest system I've taken in consideration over here. This is what the package unit we are talking about over here. If you see the footprint over here, it is been combined. Of course, this is not a standard package unit. This is a customized package unit made by one of the vendors over here. I know the name, but this is not the right forum to tell the name. But this is what is a customized package unit to serve the purpose. The entire package unit is made up of stainless steel. Even the fans are also stainless steel. So all the components are the stainless steel components. The compressors are typical compressors, and these units are also bespoke units, which is designed and constructed as per the requirement of the that particular room. So these are the maintenance spaces provided. So this is how a customized unit looks like. So in offshore sector, one of the advantages is that many of the clients, they provide a customized solutions over here based to suit your requirement. Of course, costs goes for the same drastically high, but it meets the purpose. Now in this particular slide, we are going to touch the base about the brief job description of the marine HVAC design engineer. Now you must be very excited by listening to this basics, that what a marine HVAC design engineer has to do in his day-to-day life or day-to-day work. So just to begin with, I just wish to cover this one by one. It should excel in review, preparation, checking, approving of the deliverable list, design basis, HVAC heat load calculation, P&IDs, D&IDs, duct layout, piping layout, data sheets, control philosophies. RFQ is nothing but request for quotations. MTO is nothing but material takeoff, or in normal terms it is called as a BOQ. Then the vendor document review, technical bid evaluation. PEP is nothing but a project execution plan, HVAC deliverables, and so on. Since it's a basic, again I'm repeating, I'm covering all these aspects on the first point in a detailed way in subsequent lectures. But just imagine how much responsibility the marine HVAC design engineer has to have on his shoulder. The next point goes is coordination with other disciplines lead engineers. As in the offshore or marine sector, apart from HVAC discipline, there are various other disciplines which HVAC engineer has to deal with, because HVAC needs a power, HVAC again needs a space, HVAC needs a safety requirement, HVAC has a lot to do with process department, HVAC has a lot to do with safety department. So all these disciplines are very important for HVAC, and for them also HVAC department is equally important, because without our input they cannot plan their services also. And HVAC is being a main energy guzzler, electrical also run behind us, and HVAC being the major space guzzler, the structural also has to run behind us, because we have the weight also, plus we have the space requirement also. So coordination with other discipline engineers plays a very important role over here. Point 3 is the HVAC design engineer has to be proficient in man-hour estimation, creating comprehensive designs, plans, layouts, working drawings, construction details to ensure the execution of projects are well within the time and budgeted parameters. This means that uh, when any work comes to the HVAC design engineer, he should know that how much manpower he has to utilize, so man hours he needs to estimate properly. And again, the drawings or the quality of the work which he has committed has to be again at par with the requirement of the client and the consultant. At the same time, it should fit well within the budget so that company should do a profitable business. Next point what we need to cover is carry out the detailed engineering and design activities for HVAC system in line with the client requirement. It means that a detailed engineering is up to the nut bolt level, also is expected by some of the client. So you should be able to do that to meet the client requirement. Next is having very good knowledge of the various HVAC equipment used in the project's selection of the equipment like chillers, condenser units, pumps, AHUs, chemical filters, fans, then ducting, piping layout design, etc. It means that a person should have an overall knowledge of a various HVAC equipment used in the project. That means he should be able to select the equipment based on the project conditions, and he should be well versed with the catalogs of the various equipment manufacturers and pinpoint selection of the model. He should be able to do it based on the heat load what is calculated and the subsequent project conditions. I would be touching the base on this point in subsequent sessions as well. Then next point comes in the past participation in various review meetings. Well, as an engineer, he has to participate in various review meetings also. The review meeting takes place based on the frequency which client decide, and he has to review the 3D model and he needs to check whether the AHU room is provided is sufficient or not. Is it clashing with any other discipline? So these are the jobs which he needs to be very well aware of it. Again, attending the kickoff meeting, pre-bid queries he needs to solve, pre and post order technical review he needs to conduct with client and vendor. Being an engineer, of course, you know what I'm trying to say. Again, knowledge of E&I control philosophy, fire and gas shutdown philosophy, HSE, that is health, safety, hazard and environment philosophy, E&I design philosophy. HVAC engineer cannot restrict himself only to the HVAC. He need to grow beyond it. I need to learn the HVAC, electrical also, instrumentation also. So that plays very important role for him as a professional to grow. So these are some of the basic JDs of marine HVAC design engineer. Now let's take a look of the tip to enter and succeed in this sector. Yes, I know that many of you want to make career in this sector, but as I've already told you that there are some prerequisites to enter into this sector. First, very much prerequisite is very strong fundamentals. You need to have very strong fundamentals, very strong basics. So first, before entering, you need to make sure that your basics are very strong because you need to work with international clients or international consultants who will be checking your drawings. Or if you are already working with international consultants, then there are the client who is also very strong in his fundamentals. So it should not happen that you don't know your fundamentals and your drawing is being teared apart and your management laughs at you. So you first work on your fundamentals. You know you should have very strong background of heat load calculations. You need to aware of all the steps and the reasoning behind all the steps. You must be knowing about the duct layouts, how the ducting has to be done, which are typical standards to be followed. The overall knowledge of HVAC fundamentals has to be very strong. You know how to do the pipe design, duct design, pump selection. You should know. Again, you need to have an overall knowledge. You need not keep limited only to the HVAC. You must also be aware of the electrical aspect of HVAC like fuses, switchboards. This all you should know. And again, the design aspect also you should know. Then again, you should be always willing to learn new things. So when I say new things, you should not say that now I know about HVAC, I will not learn anything. You should always show the keen and awareness to learn about the other disciplines also, what they do. like electrical instrumentation discipline, what they do and what are the typical active job activities they do. It may not be related to HVAC, but when you sit in the meeting, you need to always keep your eyes and ears open. You should always make friends with their disciplines and ask and try to gain more and more knowledge about their discipline, because knowledge never go waste. Who knows, after a few years you become, if you want to become project manager, because salary gets double over there, or suppose you get a construction manager, then management prefers only that person who has an overall knowledge of the subject. So that is the reason we keep all this requirement over here, or that is the reason where all these things come into picture. Then you need to have a greater communication skills. When I say great communication skill, it means we should not be rude, or our language should not be hurting or abusing anyone. Because as you travel internationally, the laws about the humans are very very strong. As you know, in India, we abuse each other by friendly way. You cannot do it in outside country because it is seen as an offensive and you may have to go in jail. So when I say communication skill also has to be improved, that means you should be using or choosing your word very very carefully when you communicate with the other counterpart. At the same time, this is upon the human aspect. Professional aspect, you need to convey your sentence in bare minimum words. It should be with very very effective words. So you are being seen or perceived as a leader. That's why the command over the English is very very important. Command over the language in written as well as the verbal communication plays very very major role. Plus you need to have a great patience also, because patience plays very very important role in oil and gas sector. What role it plays, I will cover it up next. But what I mean to say is that the patience you need to always keep. Next important point is a great mentor. As it is always been said that you cannot achieve or you cannot learn anything without a teacher. Teacher is one thing and a mentor is another thing. Yes, teacher teaches you the subject, but mentor is the one who guides you. Teacher won't tell you what is wrong. Teacher will teach you what is right. But mentor is the one who will tell you what is wrong and what is prevailing in the industry. Mentor is the one who will hold your hand and he will show you the path to success. So here the mentor you need to find to succeed in this career. Mentor is the one who will, teacher doesn't tell you how to find a job, but mentor will tell you how to find a job. Teacher will only teach the subject, but mentor will give you the overall knowledge of the field and how to succeed in it. So mentor, getting a right mentor is very very important. So go to the LinkedIn and try to find the right mentor for oil and gas offshore sector. Or anyway, I am there for you. You can always reach me on LinkedIn, and I'm always there to shape up the way you want in your career. So do not hesitate if you wish to make a career in this field. I'm ready to guide you over here. Our courses are there to teach you. Only thing what I need from the courses from you is the dedication, hard work, and willingness to learn, because most of it's almost 60 to 70% is theoretical and only remaining is what I can say is the calculations, because I presume that you already know the basics, so doing the calculations is not a big thing for you. So now let's move on to the next slide. Next slide is all about your question answer sessions. So if you have any questions to me, you can always reach out to the WhatsApp number is given there, and you can ask this question on this number, or you can reach out on the info@scolenberg.com, which is also our website email ID. So you can go there and you can ask the questions whatever you have in your mind. So once you clear it off, we will try to give the answers what best we can, and we are ready to help you. Again, I'm telling you that this is very very important topic, and we will be the very happy. And as I already told you that this is the basic model we have covered. So you can imagine the basic itself is going to take 2 hours So main course, how big it will be. So if you wish to make a career in this field, please go ahead, do it. Our best wishes are with you. We are ready to mentor you. Keep on focusing on the subject and make sure that you are making most of this knowledge, because this knowledge you will not get anywhere on the internet. It has been kept very, very secret, because many of the people doesn't want you to come into this field, because this is very, very lucrative. Plus competition should not be there, but I'm exactly opposite. I've already been on this industry for so long. I've already worked so long. This industry has given me a lot, so I want to give it back to the people in the industry, so that they also can make the fortune for their family. They should also able to travel the world. They should be able to see and interact and make themselves a better professional. This is all I wish to achieve through this particular course, and this is what the basic model is all about. So do not hesitate to ask us any question. We are there to help you. Do not hesitate to grill us. Do not hesitate to reach out to us. WhatsApp number is there. So make the most of this opportunity, and let's learn and grow. Good luck, and keep watching our YouTube channel also, where we have spread a lot of knowledge over there, and stay connected with us, and very good luck for your career. Stay tuned, because this course has a lot to offer to you. So wait for the subsequent modules also. Thank you.